My name is Webster Mohriak, and I'm a geologist that graduated at the University of São Paulo and completed a PhD at University of Oxford in England. I worked more than 30 years for Petrobras, a Brazilian oil company. In the past decades, I have been working as a professor at the Rio de Janeiro State University. That's an interesting question. Salt is a naturally occurring chemical compound that forms various types of evaporite minerals. These minerals precipitate in aqueous environments such as shallow seas and lakes. When I started working at an oil company in Brazil, my first interview with the exploration manager was a lifetime experience. He showed me a book on salt tectonics in the Gulf of Mexico and asked me to read it carefully and apply the concepts to the Brazilian margin. Although I was a very young geologist in my early 20s, I was impressed by his enthusiasm on the importance of salt for the future exploration of the Brazilian continental margins. The books concentrate on the significance of salt in the earth sciences, encompassing the fundamental principles of salt deposition, salt deformation, and the creation of halokinetic structures. The books cover a wide range of sedimentary basins through geological time. The first recognized salt deposits on Earth are known in the Precambrian region between Finland and Russia and in Central Africa. The book also discusses some examples of a Neoproterozoic salt basins in Australia, which were involved in major orogenies during the Paleozoic. The region between the Arabian Plate and the Eurasian Plate hosts many important Neoproterozoic salt basins, particularly in the Persian Gulf and the Zagros region. The Neoproterozoic to Cambrian Hormuz salt is associated with major hydrocarbon discoveries in the Middle East. Okay, that's an important question. The second volume emphasizes that plate tectonics controls salt deposition during two main phases: the closure of oceanic basins due to plate conversions, which results in basins affected by compression. The other phase is the opening of oceanic basins during plate diversions, which creates rifts and continental margins separated by newly formed oceanic crusts. The Persian Gulf region is characterized by salt basins that are currently under contraction and illustrates the first case. The South Atlantic illustrates the second case by developing rift basins with lacustrine environments in the early Cretaceous, which in turn developed the continental margins that are presently in the drift stage. Climate is also an important factor controlling the formation of most salt basins. Salt deposition occurred under arid conditions when solar evaporation significantly exceeded precipitation, resulting in increased salinity in the gulfs that were opened or closed by plate tectonics. Greek philosophers considered salt a vital element, together with earth, air, water, and fire. During the medieval ages, several nations traded salt as an important and extremely valuable commodity. In the modern age, salt production became an important industrial activity. The chemical and fertilizer industries use several evaporite minerals to extract potassium. Lithium has been explored from salt basins in China and from the salt flats in Chile. The first volume not only offers a comprehensive overview of the fundamental principles of deposition and deformation, but also outlines the application of different methods used in earth sciences. The second volume presents an overview of classical salt basins, including the Red Sea, the Central European region, the South Atlantic, the Mediterranean Sea, and the Gulf of Mexico. The second volume also presents an introduction to the future applications of the salt sciences in astrogeology and microbiology, discussing some extreme environments on Earth and other planets of the solar system.